good afternoon. Today we are speaking about troubleshooting maintenance for CBV. First of all, we'll use an introduction for PV or solar energy. Everybody knows solar energy, that we can take direct energy from solar, like PV. So we convert the sunlight to DC energy, or we can use it to convert it to heat, regard to CSP. Actually, our system is in the middle between the two parts, because we are using the concentrated and we are using PV, high efficiency BN junction. First of all, I will show you. This is the size of this CBV. Actually, not the dome, it's under the dome. It's about 5 millimeters, and it's efficient. The efficiency of these cells is about 40%. The working of these cells regards magnifying. So we concentrate the lights as it can show here. So all the light concentrated for the point to the point, to a focal point, where are the multi-junction, high efficiency multi-junction cells there. The problem of this system, it must be far away from the cell. So the system will be huge. So we can see there will be a problem. The system will be huge and light. So it will be easy vibration by the wind. And this system is a tracking system. If we have a wind, if we have a wind like 13 meters per second, the system will shut down, will go for sleep. Then readjust again. This will take about 10 to 15 minutes. So we are losing energy from 10 to 15 minutes from energy. Actually, we have 2 units received from Azuri as a pilot project for our university, Middle East University. So we did the job from zero until it worked. The people who came to the workshop yesterday, they saw it yesterday. So we do the infrastructure for this project. We implant all the structure materials and we fix the panels. After we fix, it's take about 1 year from us to do this job. After we did this job, we found a lot of problems. First of all, as I told you, this system is very thick and light, so it's affected by wind very easy. The second, the insulation for this system is very low. So we focus we found that after the winter time, all the panels has a lot of water inside it, which affect the cells. As you can see here, all the cells was like this. So we had to open all the cells, clean the water, remove the water, and clean all the cells. And every unit contains 8 panels. Every panel contains 60 cells. So after we did this step, we test every cell, because we found a lot of cells broken. So we test every cell to find that every cell giving 3.2 volt, and in the short circuit it's giving 1 amp. So after that we found it's okay. So we close the panel, isolate it, and if we found any problem, we swap it. We order some cells from the manufacturer and we swap it with the broken ones. Another problem was with the software. The software, if we open the software, it contains a Raspberry Pi. The Raspberry Pi is like a small computer with the size of a credit card, with a Python language, as everybody know. This system have control 2 motors. So this system is 2-direction tracker with GPS. Actually, the problems with this system, it's taking the action after 4 minutes. And everybody knows the sun is keeping moving. So the system has to follow the sun direction every 4 minutes. Unfortunately, you can take the first few seconds the top energy from the panel, which is 3.2 kilowatt, but after few seconds, this voltage, this power start dropping because the tracking is every 4 seconds. We ask the manufacturer if we have access, if they can give us an access for this software, so we can change it to every 1 minute. The second problem with the motors. As you know, we have linear actuator motors and a rotation motor. The linear is not a hydraulic, it's an electrical motor. When we had a problem when we received this motor, when we open this motor, it takes about a month from us to open this motor because there's a lot of bolts, a lot of tools, a lot of studs we require to open because these studs require to be 80 centimeters to open this gearbox. After we open this gearbox, we found that there's about 3 layers of this gearbox. The problem was the main gearbox was metal, the other 3 was plastic. So we have this problem with every layer. After we found a broken tooth. So we replace it after using a lathe machine with a Teflon one. As you can see, this is the broken teeth, which was stopping the motor from moving. And this is the new Teflon lathing gears. So after that, we swap it and install the system. We found that the system, actually only we start the system just from 4 or 5 days ago. The system started working, and as everybody saw yesterday, that this system was giving from 1.2 to 1.5 kilowatt. Because there were a problem, I should mention it before, in this system. The board side panels was in the focal point, but the starboard side system was a little bit far away from the focal point because there were misalignment between the starboard side and the board side. This was a mistake from the manufacturer. So actually, in the next few days, we'll start make alignment for the system to take the full efficiency from this system. Thank you.